All right, welcome back. Now we're here at part 2 of these notes. On the front, we were looking at multiplying rational expressions. Rational just means fraction. So now let's look at division. Let's start with a couple examples with just numbers. Okay, so 4/15 divided by 10 over 21. Well, what you do is you need to change this to a multiplication problem. The way we do that is we copy the first fraction, we change the sign, and then when you divide by a fraction, that's the same thing as multiplying by the reciprocal. Okay, the reciprocal, these are both what we call reciprocals, where you flip the fraction. So if I divide by 10 over 21, that's the same as multiplying by 21 divided by 10. And now that it's a multiplication problem, well, we can cancel factors here. 4 divided by 10 is 2 over 5. 21 divided by 15, we can divide each of those by 3. So we get 7 over 5. And what we get here, 2 times 7 is 14. 5 times 5 is 25. That's our solution. Let's just see if this works out. I'm going to take the calculator, and I'm going to take 4/15, in parentheses, I type that fraction, divided by 1021, divided by 21. So this is the original problem, and I'm expecting to get 14 over 25. Okay, I get a decimal. Let me change it to a fraction. Math. Enter, enter, 14 over 25. Okay, so the process works. When you divide by a fraction, you change it to multiplication by taking the reciprocal of the fraction. All right, so here we go. 3/8 divided by 9/16. Well, that's 3/8 times 16 over 9. Now we can reduce. 16 divided by 8 is 2 over 1. 3 divided by 9 is 1 over 3. Now we reduced everything we could. So up top we have 1 times 2 is 2. In the bottom we have 1 times 3 is 3. So your answer is 2/3. Okay, again, you could do this on the calculator. When you type a fraction, make sure you use parentheses. So 3/8 in parentheses divided by 9/16 in parentheses, which is 2/3. Okay, everything's good. All right, so now let's look at examples with variables. Well, number 9, it's a division problem. First thing we're going to do is we're going to change it to multiplication. So we copy the first fraction, that does not change. We change the sign, we flip the second fraction. One thing that actually a student taught me a while back, the way that they learned it, their teacher said copy, change, flip. Copy the first fraction, change the sign from division to multiplication, flip the second fraction. That's kind of what the process is. All right, so let's see, can we cancel? 5 over 25 is 1/5. 8 divided by 4 is 2 over 1. X divided by x to the third, if I subtract the exponents here, well, I would subtract, take the bottom one, 3 minus 1 is 2, so that's x squared in the bottom. Because the bigger exponent's in the bottom, it stays in the bottom. So up top here we have 1 times 2, which is 2, and in the bottom we have 1x squared times 5. We'll write that 5x squared. And that's as far as you can take it. Okay, number 10. All right, let's see here. We're going to copy the first fraction, but let's go ahead and factor it as well. So 3a minus 12 is 3 times a minus 4 over a squared minus a minus 12. We can factor that into two binomials. That's going to be a minus 4 times a plus 3. So there's the first fraction. I'm going to change the division sign to multiplication. We're going to flip the second fraction. So the a plus 5 on top, that goes to the bottom. 4a squared plus 12a is going to come up to the top, but we can factor out a GCF. What goes into 4a squared and 12a? 4a. So I'm going to take out 4a. Now what's left, if I divide out 4a, I get a plus, this would be 3. All right, so now everything is factored. Now you can start reducing or canceling. A minus 4 divided by itself is 1. A plus 3 divided by itself is 1. Now let's see. Nothing else is going to reduce, so we're going to multiply what's left. The numerator, 3 times 4a is 12a, and the denominator is just a plus 5. That's as far as you can go, and that's our solution. All right, number 11. Got 2 more examples here. All right, let's see. X squared minus 25. That's a special pattern. That's a difference of 2 squares. We can immediately write that as x plus 5 times x minus 5. So that was a difference of 2 squares. Now x to the third plus 125, that's a sum of cubes. So we're going to do our little This is x to the third, and then 125 is 5 to the third. Those are our perfect cubes, and we're adding those. So you take the cube root, you square the first, change the sign, multiply together, that's 5x. Then you square the last, 5 squared is 25. That's what you do if you want to do it fast. Okay, that's our pattern for a sum of cubes right there. Change the division symbol to multiplication. So the denominator was 10, now it's the numerator because I take the reciprocal, I flip it. 15 plus 2x minus x squared. Now we're not used to looking at it like this. Usually the x squared is first. So let's see if we can factor this into 2 binomials. So normally you do x and x. I'm going to do that, but I'm going to put it here because it's in the last position. Now the other thing is, one of these, it's going to give you a negative x squared, so one of these is positive and one of these is negative. Now we're looking at factors of 15 that can get us a positive 2. 5 and 3 is what we're going to do. Now let's see, the question here, this is going to be the 3 and this is going to be the 5. Okay, what happens, if I was to multiply this back out, I'd get 3 times 5 is 15. 3 times negative x, that's my negative 3x, and then this will be positive 5x. Negative 3x plus 5x is positive 2x. X times negative x is negative x squared. Now if what I did was just really confusing to you, the other thing you could have done, I could take this trinomial and factor out a negative 1. I would write negative 1 parentheses, and what happens, this would change every sign inside. It would be negative 15 minus 2x plus x squared. And then you could rewrite that. You could put the x squared first, minus 2x minus 15. Now go ahead and factor it. If you're more comfortable with that, go ahead and do it. Now here's what happens. I can cancel here. We've got x plus 5 and x plus 5. Now we have x minus 5 and 5 minus x. They're not the same, but they're opposites. Positive x, negative 5. Positive 5, negative x. I'm going to cancel those out, but when I divide opposites, what I'm left with is a negative 1. That was like the one that we did on the front. Now, when I look at what's left, there's nothing else that we can cancel. So we're going to write the answer. This is negative 1 times 10 on top. Negative 10 for the numerator, divided by, we have x squared minus 5x plus 25 times 3 plus x. You could multiply all that out, but you can leave it, I would just leave it in factored form, okay? Or else that's going to get it's going to cause you a lot more work and time if you try to multiply that back out. All right, the last one here, number 12. You have a fraction divided by another fraction. So let's change this to a multiplication problem. You take the top fraction, just copy that down, and to divide by a fraction is the same as multiplying by the reciprocal. So I multiply by, I flip this, 4x to the third over 3 minus x. Okay, let's see what we got. I always put parentheses around my binomials. Positive x minus 3, positive 3 minus x. Those are opposites. So I'm going to reduce those, cancel those, and I get -1. Now let's see, 4 divided by 12 is 1/3, 1 on top, 3 on the bottom. X to the third divided by x to the first, subtract my exponents, I get x squared. That stays up top because the bigger exponent is already in the top. So now we'll multiply here. We get -1 times x squared is just -x squared over, in the bottom here, all we have is 3. So we get -x squared over 3. That is the end of the notes. Okay, so go ahead and show those to the teacher, and now you can get your assignment.